In the previous video, we have discussed about the ozonolysis reaction and the method to predict the products of the ozonolysis reaction. And when the products are given, how to predict the starting materials has been discussed. In this video, we are going to discuss about the NCERT exemplar, that is the in-text questions from the NCERT textbook of class 11 and page number 397. So the first question is, write the IUPAC names of the product obtained by the ozonolysis of the following compounds. So the first question is, write IUPAC names of the products obtained by the ozonolysis of the following compounds. The first compound is pent-2-ene. There are 5 carbon atoms in this compound, and the double bond is at the second position. So we have discussed that on ozonolysis, it will give 1 mole of acetaldehyde and 1 mole of propanaldehyde. So how to say this? Simply, we have to break the double bond and put oxygen on either side and then write the product. So if you break it and write it, 1, 2, 3 carbon atoms, aldehyde is propanaldehyde, and 2 carbon aldehyde is acetaldehyde, that is ethanal and propanal. Let us look the other compound, 2-ethyl 1-butene. 2-ethyl 1-butene. So this is 1, 2, 3, and 4. At the second position, we have the substituent ethyl group, that is 2-ethyl 1-butene. So 2-ethyl 1-butene on ozonolysis, what we'll get? We have to break the double bond over here and then write the products. Simply break it, you will get 1 carbon aldehyde, that is formaldehyde, and this is 1, 2, 3, 4, 5 pentanone. Which pentanone? That becomes the 3-pentanone or pentan-3-one. And the next compound is 1-phenyl but-1-ene. So this is 1-phenyl but-1-ene. So we have to cut the bond over here and then put oxygen on either side. So this is 1, 2, 3 carbon aldehyde, that is propanal, and the other one is you have a phenyl ring and 1 carbon, that is benzaldehyde. So we get 1 mole of propanal and 1 mole of benzaldehyde on ozonolysis of 1-phenyl but-1-ene. So if you look at the structure, like if the alkene is not substituted, then we always get aldehydes as the product. So if you look at the double bond, there is no substitution over here or here. So we simply get the aldehyde. So if the alkene is substituted, then we get ketone as one of the product, if it is mono-substituted. And the next question is, an alkene A on ozonolysis gives a mixture of ethanol and 3-pentanone. Write the structure on IUPAC name of A. So you have to align the molecule like this with oxygen facing towards each other, that is ethanol, the CH3, CHO, and the other compound is 3-pentanone. So 1, 2, 3, 4, and 5. At the third position, you have the ketone. So just remove this oxygen and write the double bond. So the product that we are going to get is 3-ethyl pent-2-ene. So you just remove it and then number it and write the product. So here I have been telling you, like whenever you have a substitution near the double bond, then we are going to get the ketone as one of the product. So here the double bond is substitution. We have a substitution over here. So we get ketone as the product. And here an alkene A contains 3 CC, 8 CH sigma bond and 1 CC pi bond. And A on ozonolysis gives 2 moles of an aldehyde of molecular mass 44 units. So write the IUPAC name of A. So here an alkene A contains 3 CC sigma bonds. So 3 CC sigma bonds means that there are 4 carbon atoms in that. So 1, 2, 3, 4 carbon atoms. And this is 1 sigma bond, 1 sigma bond, 2, and these are the third one. And there are, after writing the basic skeleton, then we will put 1 pi bond over here, looking at, because we get 2 moles of same aldehyde. That means it could be a symmetrical molecule. If it is a symmetrical molecule only, we will get the same aldehyde. So thinking that at the second carbon, we put the double bond and then fill the valence hydrogen bonds correspondingly, taking the tetravalency of carbon. So once you place the double bond, then you write the CH, 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 and CH. So that becomes, there will be 8 CH sigma bonds. So 1, 2, 3, 4, 5, 6, 7, and 8. So that is 2-butene. So if you want to look for that, you break it, then you will get 2 moles of acetaldehyde. That is, the molecular mass is 44 units. So the compound is 2-butene. And the next question is, propanol and pentan 3-one are the ozonolysis products of an alkene. What is the structural formula of an alkene? So again, you have to write propanol. Propanol is the 3-carbon aldehyde. This is 1, 2, and 3 carbon atoms, and 3 pentanone or pentane 3-one. That is a ketone. So 1, 2, 3. At 3 position, we have a double bond O, 4 and 5. So simply you align the molecule on the paper like this, and then remove this oxygen and write it. So the product that we are going to get is 3-ethyl hex 3-ene.